We're looking at the University of Washington's Math 120 pre-calculus course. This is the winter 2016 final exam. We're given a function f of x equals 2 times 3 to the 6 minus 2x. So a complicated exponential function. And we're asked to do three things with f. We're asked to first find f inverse, and then to find a, given that f of a squared plus 1 is equal to 54. And finally, we're asked to rewrite f in a slightly more standard form, where we have just a coefficient times some base to the xth power. So let's take a look at these one by one. Let's first find f inverse. Recall that our method for finding inverse functions is to write our equation in terms of y and x, then swap the positions of y and x, and resolve for y. So I can write this. Here I've just replaced this f of x with a y. Now I'll rewrite this equation, but swapping the roles of y and x. And now I simply need to solve for y. So to solve for y, I'll first divide both sides by 2. And then I'll hit both sides with a logarithm. Any base will do, but I suppose I'll use log base 3. And now the reason for hitting this with a log is that when I hit this side with a log, this exponent comes to the front. And now solving for y is pretty straightforward. I'm going to bring the 2y over to this side and this term over to this side. And then I just need to divide by 2. And we have our inverse function. So I'll rewrite our inverse function slightly differently. This is what we're given. Doesn't look so bad. I can divide both sides by 2. And I could work quite mechanically here and simply hit both sides with a logarithm. I don't really feel like I need to think about logarithms here. In particular, I know that 3 cubed is 27. So what that tells me is that this exponent needs to be 3. So I can get quite directly this equation for a. All I've said is that this exponent needs to be 3. And this solves quite straightforward. 6 minus 2 is 4. Minus 3 is 1. So this is our solution for B. And finally, C. We want to write this in a more standard form. This is not so bad at all. Well, this difference here in the exponent I can rewrite like this. And this exponent I can also rewrite. And I already have this in essentially standard form. I can now write this now looks exactly as we want it to. So we've written our exponential function in standard form. Thanks.